The Great Salt Lake is not only in danger of disappearing completely, but is also in danger of creating a toxic dust bowl. Today we're going to discuss the factors contributing to this. The Great Salt Lake is the largest saltwater lake in the Western Hemisphere, spanning over 1,700 square miles. It is crucial to the region's ecology, economy, and air quality. However, due to the diversion of freshwater sources, climate change, and man made drought, the lake is shrinking rapidly and posing an urgent environmental crisis. Salt Lake City, which is my adopted city next to the Great Salt Lake, is at a longitude of 111.8 degrees west, a latitude of 40.7 degrees north. It belongs in the northwestern hemisphere of the United States, and Utah is a very far inland state in the United States, which means that it is not near a coastal, like near the ocean. It is 594 miles inland from the coast of the Pacific Ocean. Even though it is so far inland, though, Utah is closer to the west coast than it is to the east coast, and it sits at an elevation of 4,190 feet. Right here, we have two map images of the Great Salt Lake and its surroundings. On the left hand side, in the lower right corner, we get to see the Great Salt Lake's nearness to Salt Lake City itself. We also get to see a few marked sightseeing points like Antelope Island, Promontory Point, and Spiral Jetty. We also get to see this long red line that goes through it, and that used to be an active railroad. And on the right hand side, in the light blue around the Great Salt Lake, that is where the historic lake level used to be. Salt Lake City is centered on 105 degrees west, which puts it in the US's Mountain Daylight Time, which is 6 daylight saving time hours behind GMT and 7 standard hours behind GMT. GMT stands for Greenwich Mean Time, which is based in Greenwich, England, which is the global standard time zone. This is the global standard time zone because, according to the Royal Museum of Greenwich, the recommendation was based on the argument that naming Greenwich longitude 0 degrees would be of advantage to the largest number of people. As the reference for GMT, the prime meridian at Greenwich therefore became the center of the world time and the basis for global time zones. Now I'm going to discuss Utah's wind belt. Utah's wind belt moves from west to east, which means that it stays in the prevailing westerlies all year long. The prevailing westerlies dictate the overall movement of the air masses in the atmosphere. In Utah, the air masses typically move from the Pacific Ocean towards the east, carrying with them weather systems and moisture. As storm systems often developed over the Pacific Ocean, the prevailing westerlies bring these systems toward the western United States, including Utah. The storms can bring rain, snow, and other weather events to the region. Due to the west to east movement of the storm systems, the climate precipitation patterns in Utah are influenced. The western parts of the state, particularly areas adjacent to mountain ranges, may receive more precipitation as moist air is lifted over the mountains, leading to orographic precipitation. As the air descends on the eastern side of the mountains, it can create rain shadows, resulting in drier conditions in certain areas. The impact of the prevailing westerlies on Utah's weather can vary by season. In winter, storms from the west can bring snowfall into the state, while in other seasons they may contribute to rain or varied weather conditions. We see through our climograph and our climate record that Utah is a mid-latitude dry, semi-arid climate. We see that Utah reaches high and dry temperatures in the summer and low dry temperatures in the winter, with spring, March, April, May mostly having the largest amount of precipitation due to mid-latitude cyclones coming in. Utah is in a dry climate, as well as being in a rain shadow, but it still receives precipitation through mid latitude cyclones and the evaporation of lakes and other bodies of water. Now we're going to discuss Utah's biome. As we can see here, Utah, especially the Great Salt Lake, is found in a desert climate. This means that the weather, even though that varies by desert to desert, usually receives less than 25 centimeters of rainfall annually. While deserts may be predominantly hot or cold, most experience extreme diurnal temperature fluctuations, as we do see in Utah, which means warm during the day and cold during the night. Normally in desert climates, we see primarily woody stemmed shrubs and plants that have small leaves, thick stems, deep rooted systems, which are created in order to minimize the water loss and keep in as much water as possible. Here we get to see Utah in relation to the rest of the United States. We see that it, along with a few other states, are in this desert climate. They look very dry and they're more in the beige color. We also get to see the biomes of Utah right over here. And we see the most common animal types and another climograph right over here. The most common animal types in Utah are reptiles, amphibians, and mammals. Here you're going to discuss some of the most common landforms in Utah. Basin Range is up first, which is actually what the Great Salt Lake sits in. The Basin and Range topography occurs when the region has tension pulling in an east to west direction. The hot mantle's movement below causes the surface to come up and then partially collapse under its own weight. The region continues to have this process and it continues to stretch, causing the ranges, which are the domed up areas like the mountains around the Great Salt Lake, and then it also creates the basins, which are the collapsed areas, which is actually what the Great Salt Lake sits in. We also see lots of wave cut terraces in the Logan and Provo, Utah area, which are the outjuts that sort of have a slope down next to the mountains. So they form kind of like this and then they go down. These are actually remnants of the Great Lake Bonneville. These are flat surfaces that used to be where the shoreline of Lake Bonneville was. Lake Bonneville itself was a gigantic freshwater lake during the Ice Age that rose beginning some 3,000 years ago to wholly fill the Lake Bonneville basin of the Eastern Great Basin. And the Great Basin's internal drainage is another very interesting landform activity in Utah, which is where the Great Basin is a 200,000 square mile area that drains internally. All of the precipitation in the region evaporates, sinks underground, and then flows into lakes, which are predominantly saline lakes. This is the Great Basin. This spans across Nevada and Utah. We can see in the upper right hand corner that the Great Salt Lake is right there, and I've marked it with a red dot. Here we see the two wave cut terraces in Logan, Utah. They do jut out like I was discussing earlier, and we can see one that is 16,000 years old, which is a lot higher, and then one that is 14,000 years old that is a bit lower. So we can see that over the span of 2,000 years, the Lake Bonneville started just going lower and lower and lower. The Bonneville Salt Flats are a major landform in Utah. They formed when Lake Bonneville started drying up and started evaporating, and once it fell below its outlet, the water became salty. And then once that salty water started evaporating, all the salt started compacting together and formed the salt flats that we now know. Here's an image of the Bonneville Salt Flats in all their glory. Now we're going to delve into the reason why the Great Salt Lake is salty. As stated by the Utah Geological Survey in 2022, the high salt concentrations are a result of the lake not having an outlet. The Great Salt Lake occupies a topographical bowl with no stream exiting the lake, and therefore it does not have a way of expelling any of the salts that enter the lake. And each year, several million tons of dissolved salt are added to the Great Salt Lake from its tributary rivers. Sorry. Evaporation is the only way water leaves the lake. On average, the lake loses billions of gallons of water a day to the atmosphere. As the water evaporates, the salt forming minerals are left behind, concentrating over time. The Great Salt Lake, for the Great Salt Lake, these minerals are composed mostly of sodium chloride, similar in ratio to the ocean, but typically several times greater in quantity. Like other closed basin lakes, known as endorheic lakes, the Great Basin and lakes in arid regions around the world, Great Salt Lake has a high and variable concentration of dissolved solids due to its drastically changing volume. Lake volume at any given time is a function of the weather in its basin. The melting of heavy snowpack in mountains can cause large rises in lake elevation during the springtime, diluting the salinity, and persistent droughts will drop the lake level year after year, concentrating the salts. Now I'm going to discuss the human impact on the Great Salt Lake. The salt industry has had one of the greatest impacts on the Salt Lake itself. Due to the Salt Lake's naturally occurring abundance of salt, it has attracted lots of manufacturers, such as Morton's, American Salt, etc. These companies started to divert naturally flowing rivers away from the lake in order to preserve the salt. Subsequently, the lake has started drying out and has lost most of its water. The salt industry has been put above the lake's livelihood, the lake's ability to thrive. But if the lake continues to dry out, and when the lake continues to dry out, the salt industry will die as well, because the ability to harvest the minerals from the salt lake will no longer be available. The drying of the Great Salt Lake has large environmental impacts as well. Firstly, the flies and the brine shrimp in the lake will die off and are dying off. The drying of the lake bed is causing mass die offs of flies and brine shrimp that birds rely on for food. This leads us to the threat on migratory birds in the area, which the loss of food sources puts the migratory bird population at risk, the ones that rely on the lake as stopover, which is their food supply. And once their food supply is cut off, they will die off as well. The drying of the Great Salt Lake is also affecting the ski resorts and the ski conditions. The declining snowpack due to less lake effect snow is worsening ski conditions at Utah resorts. And also, the further drying could halt mineral extractions from the lake, which is impacting jobs and revenue. So we see that not only the lake will be lost in this drying. This is a quote from Joel Ferry, the director of the Department of Natural Resources in Utah. He's discussing the impact, the environmental and impact on humans in the area that the drying of the Utah Salt Lake will have. There will be many health risks due to the declining air quality in Utah as the Great Salt Lake starts shrinking. First of all, arsenic exposure will be very prevalent. The shrinking of the lake size exposes the arsenic deposit in the lake beds, releasing it into the air. This will cause respiratory issues. Airborne arsenic particles from exposed lake beds increase the risk of lung disease for residents. Cardiovascular ailments like from arsenic exposure is linked to hypertension, atherosclerosis, and heart disease. These high arsenic levels are at a level of 278 ppm of arsenic, which far exceeds the EPA safety levels. And this will create a poisonous air. The arsenic makes the air increasingly poisonous and unsafe to breathe as the lake shrinks. We lightly discussed the economic impacts of the lake dry up earlier, but now I'm going to go a little bit more in depth. The salt evaporation ponds. The solar evaporation ponds of the mineral extraction industry will dry up without sufficient lake water levels. Also, the ski resorts. Decreasing snowfall due to the drying up of the lake will severely impact the ski industry and winter tourism, which is a huge economic contributor to Utah. And finally, the $70 million brine shrimp and mineral extraction industries will collapse if and when the lake dries up. I'm going to discuss some factors contributing to the lack of water in the Great Salt Lake. First of all, global warming has had a slight impact on the lake evaporating, therefore taking more water away from the lake. Population growth has had an impact on the water usage in the area, taking away more water from the reservoirs. More residents are taking up more water. The largest impact has been the diversion from rivers feeding into the lake. Now there is no water being added to the lake. There's more evaporating. Therefore, the lake is just starting to dry and dry and dry without any more water being added into it. Conservation efforts have been made lightly. There's been mostly suggestions that Utah residents use less water so that there's more water to put into the lake. But other than that, there haven't been many conservation efforts being made by the Utah government. Dr. Robert Gillies, a professor at Utah State University and a Utah State climatologist, said to the New York Times, "If you don't have water, you don't have industry, you don't have agriculture, you don't have life." Once the Utah Great Salt Lake dries up, we will no longer have the mining industry, this mineral mining industry for salt. We will no longer have agriculture. The precipitation from the Great Salt Lake will be lost. And the Utah state itself will become a toxic dust bowl. It will become inhabitable. Here we see the satellite images from 1987 and 2022. We see how the satellite image in 1987 shows us an abundant Great Salt Lake with ample water flows, with ample water levels. And when we look at 2022, we see that it has shrunk dramatically and a lot more shallow. There's not that abundance of water that 1987 had. Here I have a table showing us the huge economics that both these industries give to Utah. The mining industry gives at least $1.32 billion a year to Utah's economics, and the brine shrimp harvesting industry gives $57 million to Utah every year. Here I have the fluctuation and trends in the water level of the Great Salt Lake. We see the water levels rose in 2022 due to the increased salt pack, but they dropped in 2023 due to the arid climate, the dryness of the area. And if this continues the way that it's going, by 2025 we're projected to have a continued decline without intervention. I had the privilege and pleasure of speaking with Professor Jeff Monroe, who specializes in geology at Middlebury College, but has a great interest and has published research on the topic of the Great Salt Lake and the effects of its evaporation. These are 3 points that he discussed are most important for everyone to know about the Great Salt Lake and its evaporation. He re-emphasized that the Great Salt Lake has a huge economical significance and is a major contributor to the Utah economy. Both of these positive impacts are in danger of being lost if the lake shrinks any further. Although the climate is warming is a minor component to the ongoing decline of the lake, he reinstated that by far the most important reason why the lake is shrinking is that people are diverting too much water from the rivers to flow into it. And finally, the lake is shrinking so fast that it is in danger of disappearing completely. Even the big snow last year wasn't enough to reverse the declining trend for the long term. As Professor Monroe states, if we do not start trying to rehabilitate the Great Salt Lake, we risk not only losing it altogether, but we also run the risk of creating a toxic dust bowl and possibly making Utah uninhabitable. We will lose the ability and the privilege to see Utah's beauty, and Utah could possibly become one big ghost town, and that is truly terrifying. Here are my research references, and here are my image references.